Hi everyone, welcome to Mr. Wagid's math class again. Today we will be discussing something new, relations and functions. I want you to think about those examples. Is there a relation between the amount of money you pay per pack of markers? Is there a relation between the money you pay per pound of tomatoes? Is there a relationship between the speed and miles per hour? Or is there a relation between the number of students and a teacher in a classroom? So how can we organize a relation in math? We can organize a relation in math as an ordered pair, x and y. The input-output table that has the input and the output in a table. Mapping diagram that also has the input and output. Graph that has the x and the y. Equations, and that would be y equal 3x plus 2, or when you have y equal x squared plus half, or any equation. Words can also, we can organize a relation in words, such as the input is 3 times the output. Relation pairs input with output, as you saw in all different ways of organizing a relation. So a relation that pairs each input with exactly one output is called a function. So a relation can be a function or it cannot be a function. For you to understand that, how can a relation be a function if every input has exactly one output? To make it easier for you to understand, if you have a person and his date of birth, the input is the person and the output is the date of birth. And I'll start with me. My date of birth is November 13. I'm not giving you the year though. Mona's birthday is August 17. Nancy's birthday is April 16. But then John's birthday is November 13. Did you notice something? The input, each person can have one date of birth. I can't have 2 date of birth. If I have 2 date of birth, that's impossible. So it's not a function. Can 2 people have the same date of birth? Yes. That is a function because the input has exactly one output, one date of birth. So a function, when every input has exactly one output, but the output can have 2 different inputs. Always remember, x is the input and y is the output. Let's determine whether the relation is a function and start with an ordered pair. And always the ordered pair, we start with x and then y. X is the input and y is the output. Here's the first example. Look at all the numbers in red. They are the inputs, and all the numbers in black are the outputs. Does every input has exactly one output? Let's see. -2 has one output, which is 2. -1 has one output, which is 2. 0 has one output, which is 2. 1 has one output, which is 0. And 2 has one output, which is 0. So yes, every input has exactly one output. Therefore, the relation is a function. Let's look at the second example. 4 is an input and the output is 0. 8 is an input, the output is 7. 6 is an input and the output is 4. Now 4 is an input, the output is 3. Did you notice something? The input 4 has 2 outputs, 2 different outputs. One of them is 0, the other one is 3. So does every input has exactly one output? No. So the relation is not a function because the input 4 has 2 outputs, 0 and 3. If you notice the first example, I can have the same output, but I cannot have the same input with 2 different outputs. Now let's determine whether the relation is a function from an input-output table. Here's a table. Always the first row is the input, the second row is the output. Always the first row x, the second row is y. Look at the inputs. 16 has an output -2. 1 has an output -1. 0 has an output of 0. 1 has an output of 1. 16 has an output of 2. Did you notice that the input 1 repeated twice with 2 different outputs? So the relation is not a function because the input 1 has 2 outputs, -1 and 1. So it's not, this relation is not a function. Now look at this second table. Again, always the input first, the output is next. -3, the output is 11. 0, the output is 5. 3, the output is -1. 6, the output -7. And 9, the output -13. Does every input has exactly one output? Yes, none of the inputs are repeated. So the relation is a function because every input has exactly one output. Here's another example. Determine whether the relation is a function, but this time from a mapping diagram. In a mapping diagram, let's start with number 5. Look at the input. Always the input x is first, the output is second. Whether we go vertically or horizontally, the first row or column you see is always the x, or the input. So 0 has one output, which is -3. 1 has one output, which is 0. 2 has two outputs, 3 and 2. So is it a function? No. So the relation is not a function because the input 2 has two outputs, 3 and 2. Now let's look at number 6, the input and the output. Look how -10 has an output of 1, -8 has an output of 1, -6 has an output of 2, -4 has an output of 2, and -2 has an output of 2. Does every input has exactly one output? Yes. Every input has one output. Even though the output is shared with so many inputs, it doesn't matter. What we look at is the input. Does it have one output? Yes. So the relation is a function because every input has exactly one output. Again, let's determine whether a relation is a function from graph. And graph has an x-axis, which is the input, and the y-axis, which is the output. A graph represents a function when no vertical line passes through more than one point on the graph. So here are 3 examples of a graph. Let's start with the far right and draw a vertical line and see if that line passes through 2 points. Here's the red line first. The x-axis, or the input, is 3. Watch how it passed 2 points on the line. Same another line on the 2, input 2, also passed through 2 points. So the line passes through more than one point on the graph, which means it's not a function. That means those inputs has multiple outputs. Let's look at the second graph. Draw a vertical line. Did it pass through more than one point? No. Draw a second line any way you wanted to. Did it pass through 2 points? No. Therefore, the relation is a function because every input has exactly one output. The last example, draw the red line. Watch how it passed the 2 points. Draw another line. Watch how it passed also 2 points, which means the input 4 has 2 different outputs and the input 2 has 2 different outputs. So passed through more than one point. Therefore, the relation is not a function. Now we will add some more vocabulary to the lesson. Domain and range. Domain is the same as the input or the x values. Range is the same as the output or the y values. So the domain of a function is the set of all possible input values. The range of a function is the set of all possible output values. So let's look at those 2 graphs. Let's start with this first one. Write the ordered pair first. So what is the domain? It goes from -2, -1, 0, 1, and 2. All these are the domain values. The range is the y values. So what is the y values from the ordered pair? So the y value is -2, 0, and 2. Do I need to repeat the 0 and then -2 again? No. So we know it goes from -2, 0, and 2 only. Now let's look at the second graph right here. There is no dots. So it's not just one number. It's not an integer. So because it's continuous, that means all the numbers in the domains and the range, not just 2, 4, 5, 6, 7, it's everything in between. So 2.2, 2.3, 4.5, 4.6, so all the decimals until you get to the integer itself. That's why it's continuous. It's going from 2. So look at the x-axis, draw a line from where it starts to end, and that would be your domain value. Draw a vertical line to the y and see where does it start to where it ends, and that vertical line is the range or the y values. So let's think about it and write it as an inequality. The domain starts from 2 to 7, so x is more than 2 and less than 7. And the range is y, and its ranges from 1 to 6. More than 1 and less than 6, that is the range. And I did not put less than or equal because it's an open circle. Open circle, that means that number is not included. I will add 2 more vocabulary words for this lesson, and I know you heard them before. Independent, dependent. Independent is the same as the input, x values, or the domain. Dependent is the same as the output, y values, or the range. Do you remember the function machine from last year? The output depends on what you put in the machine, so the output is y and the input is x. The output is dependent and the input is independent. So when you hear y is the function of x, that means y values depend on the x value. So let's see if this statement is true. The cost is a function of the number of pounds of tomato you bought. Is that a true statement? Yes, the cost depends on the number of pounds x you buy. So you know that the cost depends, so the y is the dependent and the x is the independent, which is the pounds of tomatoes. Now let's go over a word problem. The function t equal 19m plus 65 represents the temperature T in degrees Fahrenheit of an oven after preheating for m minutes. Identify the independent and dependent variable. What do you think? Which value depends on the other? Does the temperature depends on the time, or does the time depends on the temperature? Think about it. Time passes anyway. It's independent. But the temperature of the oven depends on how many minutes passes. It increases every minute passes. So m, the minute, is the independent variable, and t, the temperature, is the dependent variable. So temperature depends on the minutes. Now, a recipe calls for an oven temperature of 350 degrees Fahrenheit. Describe the domain and range of the function. Again, domain is the x and the range is the y. Now I need you to write the equation t equal 19m plus 65. The equation shows the starting temperature of 65 of the oven, but then it increases at a rate of 19 degrees per minute. How many minutes does it take to reach 350 degrees? Write the equation, substitute what you know. And I know the temperature is 350 degrees. So write 350 degrees equals 19m plus 65. Now solve for m. How many minutes does it take to reach 350 degrees? The subtraction property of inequality, subtract 65 from both sides. You end up with 285 equals 19m. Now the division property of inequality, divide by 19 both sides, and you got m equals 15. That means it takes 15 minutes for the temperature to reach 350 degrees. So what's the domain? What's the range? Explain that. The domain is m, which is the number of minutes, from 0 minutes up to 15 minutes. So how do you write that as an inequality? It's 0 less than or equal to m, less than or equal to 15. And I put equal to also because 0 and 15 are solutions. The range is the t, and the range is the temperature, which means it starts from 65 up to 350. It goes from 65 to 350 degrees. So 65 less than or equal to t, less than or equal to 350. That's a compound inequality joined with the word and. So it's a range from 65 to 350 degrees. That's it for today's lesson. You guys have a great day.